Good morning everyone. Welcome again in the physics class of motion in one dimension. In this video, firstly we will discuss about syllabus. Children, motion in one dimension. Syllabus is that scalar and vector quantities, distance, speed, velocity, acceleration graphs of distance, time and speed time, equation of uniform accelerated motion and derivation. Scope. Examples of scalar quantities and vector quantities only: rest and motion in one dimension, distance and displacement, speed and velocity, acceleration and retardation, distance, time and velocity time graphs, meaning of the slope of the graphs. Children, non-uniform acceleration excluded, equation to be derived: v equal to u plus at, s equal to ut plus half at square, v square equal to u square plus 2as. Equation for the ascent is not included. Simple numerical problem. Children, some terms related and in motion. What is scalar and vector quantities? What is the meaning of quantities? It is a property that can exist as a multiple or multitude or magnitude which illustrate discontinuity and continuity. Quantities can be compared in terms of more, less or equal, or by assigning a numerical value in terms of unit of measurement. Children, what is scalar and vector quantity? Scalar quantities the quantities which can be measured are called physical quantities. Physical quantities are classified into the following two broad categories. Number 1 point, scalar quantities or scalars, and vector quantities or vector. Children, first I will discuss scalar quantities or scalars. We know that the physical quantity which have only magnitude, and no direction are called scalar quantities. A scalar quantity can be specified by a single number along with the proper unit. Very important part is scalar quantities. For example, mass, length, time and distance, density, volume, speed, temperature, potential, magnitude and electricity, etc. Children, unit of mass is the kilogram, unit of length is meter, unit of time is second, unit of distance is meter, etc. Scalar quantities can be added, subtracted or multiplied and divided by simple arithmetic method. A scalar quantity is symbolically written by its English letter. For example, mass is represented by m, time is represented by small t and speed by small v, temperature represented by theta degree centigrade and amplitude is represented by small a. Okay? Children, what is the vector quantities or vectors? Very important part. These physical quantities require the magnitude as well as the direction to express them, then the only their meaning is complete. Or Other meaning of vector quantity, the physical quantities which have both magnitude and direction and obey the laws of vector addition are called vector quantities. Or a vector quantity is specified by number with a unit and direction. For example, 10 kilometer. It is a scalar quantity because it has only magnitude but not direction. Similarly, 40 kilometer east. 40 kilometer is magnitude or east is direction. It has vector quantities because according to definition of vector, it has magnitude as well as direction. 40 kilometer is the magnitude and east is direction. Children, now consider 40 kilometer 30 degree. 40 kilometer is magnitude and 30 degree is direction. It is also vector quantity. Okay children? For example of displacement, for example of vector quantities is displacement, velocity, acceleration, torque, moment of force, etc. It has required the following three parameters to express a vector quantities. Number one, unit, direction and dimension. Third point, numerical value and quantity. For example, 10 kilometer for 35 degree. So 10 is numerical value, kilometer is unit and it is the direction. If it has 10 kilometer, then 10 is numerical value and kilometer is unit. It is vector quantity. It is a scalar quantity. In short, if any object has magnitude but not direction, it is a scalar quantity. If any object has magnitude as well as direction, is called as the vector quantity. Okay children, now I will discuss rest and motion. Rest and motion. Very important part is the motion in one dimension, that is rest and motion. Rest and motion. We know that rest and motion, every object in the universe is in motion. Every day we see bodies moving around us. For example, birds flying, cars and bus moving, people walking, insect crawling, animals running, etc. Our earth also moves around the sun. To everything on the earth is in the state of motion. The sun and stars are moving around the center of their galaxy and the galaxies too are at the rest. So children, we know that the rest and motion according to Newton's first law. We know that according to Newton's first law of motion, if a body is in a state of rest, it will remain in the state of rest, and if it is in the state of motion, it will remain moving in the same direction. with the same speed unless an external force is applied on it. Very important part, rest and motion. It is taken by Newton's first law. Newton's first law can be understood in the following two parts. Number one, definition of inertia. Second, definition of force. Definition of force. Right? So, definition of inertia. In the first part, Newton's first law gives the definition of inertia according to which an object cannot change its state by itself. For example, a book lying on the table top will remain placed at its place unless it is displayed. Next part, definition of force. It is second part of the inertia. It is the second part of the Newton first law. The second part of Newton's first law defines force, according to which force is that external cause which can move a stationary object or which can change the state of motion or of a moving object. Examples, a book lying on the table gets displaced from its place when it is pushed. Okay children, now discuss one dimension motion. When a body moves along a straight line path, its motion is said to be one dimension motion. For example, x-axis and y-axis and z-axis. Right? A particle moves in this direction, one dimension motion. A particle move in z direction, y-axis, therefore it has one dimension motion. If particle move z direction, it is one dimension motion. If particles move x and y, that is two dimension. If body moves from y to z, it is two dimension. If body moves z to x, that is two dimension. Because direction has been changed repeatedly. Okay children, we know that representation of one dimension motion, it is graph. Example, the position of the pebble measured by its starting point falling freely and vertically downwards of different instants is given in the table. That is, if time is 0, then position is 0. If time is 1, position is 5. If time is 2, that is position is 20. If time is 3, position is 45. If time is 4, that is position is 80. It is given in this diagram. Okay children, next part, distance and displacement. We know that distance and displacement, distance is a scalar quantity and displacement is vector quantity. If any body moves from A to B 5 km, if any body moves from A to B 5 km and move from B to A 5 km, if any body move A to B, that is 5 km, and body move B to A is 5 km, yeah, 15 km. So distance is equal to 5 plus 15, that is 20 km. Okay children, 20 km. And displacement is equal to 5 minus 15, because direction has changed. That is minus 10. Okay children. If a object move to B position, it covers the distance 5 kilometer, and B move to A direction, that is it covers 5 kilometer, right? So distance is equal to 5 plus 5, that is 10 kilometer. Distance is not depend on the direction. Distance is not depend on the direction. But displacement is depend on the direction. Therefore, displacement equal to 5 kilometer minus 5 kilometer, that is 0 kilometer. Okay children.